So I received this email, and it says, "Hey John, I came across a token or session stealer posing as a repository that I helped contribute to. I had some fun decompiling and deobfuscating the file, and I figured you might as well. They include the links to the actual project and the infected project, and he includes the whole infected jar file. It is Java, a Java archive, from the releases of the infected repository as a zip file, as well as the main stealer itself as a separate zip file, as it's located confusingly deep within the Java structure itself. The file is a mod for Minecraft, which in itself has obfuscated game code, so there'll be some things, symbols called like field underscore 71412 underscore D or whatever, and they'll appear in the decompiled Java file. However, the mappings for that version of Minecraft, I assume 1.8.9, can both be found here and here. They included that link. We've got the password for the zip archive, and this individual, David, hey, big thanks, David, they've already reported both the GitHub project and the web host address of the attacker. But it should be a little bit of fun to deobfuscate the code and find the juicy IP details of the attacker. So let's dive in. Before we go straight into the code, I will show you this repository. Apparently this mod is for Sky Hanny, a Minecraft mod for high-pixel skyblock. Now, let me say, I know absolutely nothing about modding Minecraft or Minecraft hacking or anything of that sort of nature, but I do know maybe a little bit about malware. And usually info stealer malware coming alongside of a video game is just all the time how people are infected. So we could see the infected repository, though David let us know, hey, that repository has been reported and now since taken down. He also included the symbols here, or at least the links to these for, I think, Minecraft Forge or some of the things you could do to mod Minecraft. And again, I don't know any of these. Apparently it's just a list of good representation that the community has already analyzed and reverse engineered for Minecraft. Kind of cool, kind of neat, but I don't know if it's something that we'll particularly need while we dig through it. They include another just as well, but look, let's just get to the code. Now, I am inside of Remnux, the reverse engineering malware Linux distribution, and I'll go ahead and hit Ctrl-Alt-T on my keyboard to open up a terminal. I'll full screen that and zoom in a little bit, and let me move into the directory that I created for this malware in the Minecraft mod. Now, I have these two zip files that were included in the email attachments ready to work here. We have the infected jar.zip and the infected tweaks java.zip. We could go ahead and use 7-zip to extract these. We'll just get the infected jar.zip. The password included was 12345. That will go ahead and stage that out for us. If we were to run file on that infected jar, it thinks it's just a zip archive, but it is a jar file. They are oftentimes one and the same, really. We can go ahead and extract the other infected tweaks Java, and that, again, same exact password. We'll go ahead and pull that down. David had mentioned in his email that he pulled out the source code pertinent to the stealer and the malware component, but we could go track it down inside of the jar file itself. So let me actually make sure that has a good file name, or the file extension here. We'll add a .jar at the end of it, just in case, I don't know, things start to whine or it needs it, because we'll use the utility JDGUI. Now, I believe this comes with Remnux. You could probably track it down, find it on GitHub or some other resources online, but if we open that up, now we could go navigate to actually interacting with the infected jar.jar file. I'll open this, and this will decompile, so to speak, a lot of the code that was present in that Java archive. Now, again, this is supposed to be a Minecraft mod, so it's filled with stuff that I don't know and don't understand. But if we got to take a look around at some of these, if you wanted to explore or dig into the syntax, you certainly can. They did note, though, at least in the file names, this came with like a tweaks syntax. So I'm curious, this env.lib, that includes a tweaks.class that looks a little bit sketchy. If I were to actually expand this, I'm not sure. Can I zoom in here? Will that actually make the text bigger? Yeah, excellent. Here you can see everything needed to work with this package, import things pertinent to Minecraft, like net Minecraft Forge, blah, blah, blah. And then this public class tweaks is a little bit odd. It has a static void for a function called LL that defines a variable I set to this big collection of strings that are all of these seemingly base 64 encoded strings and another entry included. Odd, peculiar, seemingly hiding something, but again, Minecraft is usually obfuscated. I appreciate David cluing us in that, hey, this is in fact the malicious code. If we wanted to hop back over to the terminal, we could see that just as well. I'm using Terminator, by the way, so I'll just use a Windows hotkey, like Windows key and down. You can configure that to actually open up another terminal. But if I were to actually open up, I'll use Sublime Text here, the infected tweaks Java file. That is, setting the syntax to Java within Sublime Text, this is the exact same file that we saw inside of JDGUI. This is all the syntax just extracted and pulled out. You can see putting these back to back, JDGUI has some trouble with decompiling some components of it, but it's all the exact same code. I'll work with this within Sublime Text since we're really just kind of wanting to work with the syntax in the code itself. We've really just used JDGUI to decompile and get that code. Now, scrolling through, we see our LL function that's defining all of these odd entries in a big long list with base64 encoded stuff, presumably. There's another function here, just the letter I, that is doing something or trying to with DES, the data encryption standard, one encryption method in cryptography to be able to, hey, manipulate that data and at least, hey, have a key set to it. I'm going to assume maybe all of these functions or variables, things that are set here with the I function, are using DES or DES with a key provided as another argument. You can see that here. If we actually try to search for that, it's going to be used as the parameter, argument, and piece of actually decompiling decrypting with that crypto scheme. There might be some others here, but pre-init is another function that's interesting that has a little bit more Minecraft components to it. An event handler with initialization function, I assuming, that ends up with obfuscated variable names, right? Obviously, this all looks like nonsense, but that actually makes an HTTP URL connection based off of one URL from our L array with the encrypted and encoded data up here. A little bit interesting, a little bit peculiar. Just as we noted in the email pretense, hey, this is just probably going to be an info stealer. It's going to steal your, maybe, I don't know, Discord credentials, Minecraft information, anything that might be able to pull out. So what we might be able to do, if we wanted to dig through all of the syntax, we could, and you'll note some of the fields or the Minecraft symbols that they reference, could we unravel this? Could we see if we can decrypt those big long string values at the top and get a better idea as to what it's sending and where it's sending all that data to as it steals it and detonates that malware payload? We can keep scrolling because there are more functions for us to examine here. We're nowhere near the end of the code yet, but at least getting close. Here's another function, this L presence, and that actually looks like it's using another argument and parameter with now just simple base64 decoding that tries to get bytes and convert it to a character array and spit it all together some way, somehow. Okay, then we have another for LI, seemingly a trend with this obfuscation technique, and that ends up using Blowfish as a crypto scheme here. So we have DES, we have Blowfish, maybe some strings in the mix, and another LII that is doing a lot of XOR operations with random numbers and digits and probably manipulating something some way, somehow. So that's peculiar. But look, later down, we are getting to the end now, there is a subscribe event. And I'm going to assume in the Minecraft modding realm, this means that when a player first joins, I don't know, a server or another Minecraft world, then it will fire off some of these functions based off of an event that's passed in, trying to see if it could, I don't know, have some little small techniques to obfuscate or at least make some behavior that looks strange in different conditions as to whether or not a variable that's passed in was true or false or whatever, just misdirection here. Really, it ultimately ends up executing stuff based off of the functions. So we could use all of this as good context to try and unravel all of those encrypted and encoded strings. In fact, we might be able to put together our own little decryptor since we have the syntax here. So I wonder if we could try that. Let me build out a Java class, some Java source code, try to compile it, and then use the code even to unravel itself. Like, I don't need to care about all these obfuscated names, L-I-L-I-I, whatever. That is something we can just sort of zoom out and abstract away because we can smartly take the pieces that we might need to be able to extract all these. So let's do it. Let's try to create a new file, and we can call this like decryptor.java. It is a Java file here. And let's import all the things maybe necessary for working with this. Maybe some of these we don't need, but we do certainly need, hey, all the cipher and crypto operations here. Can I pull those down? We don't need the Minecraft stuff because we just want to unravel the strings and the data here, but let's try to put those in, and let's remove the Minecraft chunk. And then we can copy and paste the same sort of syntax that ends up building a class for us to work with. We called ours decryptor so that it has to match, given the name of the file that we chose with Java. Once we've created that, we'll end up building out like a public static main function, I think. I forget how to do all that in Java. I'm really not a Java guy by any means. Let me just do a super simple sanity check. Can I system out println? I think that's how you just do standard output in Java. We'll do a dumb, simple hello world with all that stuff imported, and let's see if we can compile that and work with it back on the command line. So let me use javac to compile our decryptor.java, and let's see how wrong I was. Oh, yep, okay, totally missed something. We don't have org Apache commons string escape utils. That's fine. We probably don't even need it. Let's go ahead and remove that import and then get back to compiling this. And it seems to work. No errors there. So let me run, now that we have that in our current directory, a decryptor.class file. We'll just tell Java to go ahead and run our decryptor. And that, oh, breaks. It needs a capital M for main? Are you kidding me? Oh, lowercase. I was wrong. How about this? Will that work? Nope, recompile it. Duh, I'm stupid. How about now? Oh, you need the arguments too, dude. All right. This video is off to a great start. Let's just use the exact same sort of declaration that they used. And how about now? I promise we'll get there for a stupid hello world in Java. There we go. Okay, now we can piecemeal some of the components from that payload, the info stealer itself, and let's see what we could build. If we actually look back here, we know that, well, ultimately, there are some functions that will stage our LL and all the other things that we do to get this big long list of strings. In fact, it's all based off of this int L array, so we should probably specify that just as well. We'll include that, and I can put these side by side just so you can see them in action. Let's move this over to the right side, and then let's move our code over to the left. Now, I'll add in that public static final int L, have that declared for us, and then this function up here, private static void LL, let's copy and steal and maybe manipulate just a little bit. I want to go ahead and bring that here, but I actually don't want to deal with this I variable, because what I'd love to be able to do is just have these functions that would decrypt all of the crypto, scheme, string, encoded, encrypted data, just spit it out onto the terminal. Like, let me see what the value is, because that's all I really care about, not gonna lie. So what I'll do is remove this dumb I variable that's defined up here, and I'll go ahead and select all of these lines in Sublime Text. I am using Sublime Text as my editor of choice. Of course, you might use whatever you prefer, but with Sublime Text, I can actually use the hotkey Control-Shift-L, and that will make multiple cursors across multiple different lines. So if I wanted to just chop out the first chunk here that sets this inside of that I variable. Again, I don't need it, but you see a little bit of the white space is wrong here. So let me use Control-Shift and the arrow keys to move smartly between word boundaries. With that, I can select all the stuff prior to just running the function to decrypt them and clean it up. With that, we are looking good. Now we've got all of that defined and running inside of our LL function. But what else is done in the actual payload? Of course, we'll need these functions themselves, like for DS or Blowfish or the others, and we can collect these. Let's go ahead and bring them back into our little playground on the left-hand side. We'll just slap it in, nice and easy. We'll keep going back and forth, but we don't need any of the Minecraft stuff to worry about, because I'm not going to run this within Minecraft. As much as I love the game, I haven't played it in however many years. Other than Log4j, there's this pretty sweet video. I was happy about the Log4j video. Let's get the other one, the other encoding function L, and that just does some string manipulation. So let's copy that, bring it into our capability here, and let's keep cruising. This is all we're doing. It's super small, super simple, just abstracting out, look, all of those crazy variable names. We're just going to ignore them, but understand, look, these are the puzzle pieces that it all actually works with. We can grab the very same for our Blowfish capability. Let me drag that in, copy and paste. And you might notice one thing down below that is actually building out probably the capability of this package. We actually have some static stuff defined where it calls LII, and LL. Now we know that LL just above is where we define all of the encrypted strings and the data that we're really interested in. So that happens second. But something happens before it, in which case our LII function. Now that we can see down below, if we actually double click, you'll see that's highlighted. That's going to end up changing or setting some of the variables and the values inside of that big L array, where all of this was already staged to start with. So part of me wonders, look, can we just take this, make sure that's capable and worthwhile for us, and then let's get that in our code. You know what? I'll bring that above, actually, just so we know that, hey, that's probably following the declaration of all of our encrypted strings. So now we have that staged and ready for us. But what will be our main function, as we want to actually execute this locally, just as some script, just as some program that will run to decrypt all the data, not within Minecraft, not as a package, we basically want to still have the same functionality as that little static call here for LII and LL. We're just putting them in place so that they're able to be called in the good placement. We'll modify our little print line to decrypting strings, and then we'll call our LL and LLII, whatever. I'm saying way too many of these letters, just out and about there. We don't need to wrap that in static. We can just call those functions, and white space is getting all weird because of the copy and paste, but look, it doesn't matter, honestly. Now, since the current execution of these functions, I, L, Li, and all this crap, doesn't actually do anything, it just decrypts the data but doesn't use them in more of the payload right now, all it does is return the value out, and we're not storing that, we're literally just calling the functions. I think we're okay to try and sanity check ourselves and see, will this even execute right now without any errors? Will it compile and work well for us? So let's get back to our terminal, and let's do that same process. We compile it, and okay, we're already broken. Cannot assign a value to a final variable L. That's defined there on line 82, we can see. So can I just get rid of that? I'll hit Control G in Sublime Text to jump to that. Can I just remove that, and maybe then it'll work and go away? Let me try that. Okay, that error's gone. I think we had 4 errors to start with, and now we're just down to 3. But now we're doing some other oddball stuff. Incompatible types, cipher cannot be converted to a short. Well, yeah, because it's an object. Why? That's weird. Why is that done to begin with? A short cannot be dereferenced. Well, yeah, you're trying to do functions from a cipher object. I don't think that those should be defined as short. I feel like those should just be a cipher type. Is that right? Let's try that out and see if we have less errors now. Java C, 4 errors. Okay, no, I made it worse. Now, I'll be the first to admit, this is where I would press the easy button and I would say, ChatGPT, can you please tell me what I'm doing wrong? Because I don't know Java, and I think this code should run, considering we got it from malware and a payload that was seemingly already functioning, but we're just getting the syntax wrong and we can't play with it the right way. So let me just do that. I'll copy and paste this in the air and see if it can sanity check me and tell me what I'm doing wrong, and maybe it'll even be able to deobfuscate or unravel some of these variables, even though they know we're just staging those crypto schemes. But actually, that might be a fine segue while we're chatting about artificial intelligence and our AI overlords. Using that especially for code review, I'd love to tell you a little bit about the sponsor of today's video, Snyk. I use Snyk to scan for vulnerabilities in my software development projects. And if you aren't familiar, Snyk scans your code, dependencies, containers, and configurations in real time, making it super easy to keep your application secure. You can use Snyk for free forever with my link below, and you can import your repositories and let Snyk do the work for you to find and fix your vulnerabilities. And there's some pretty cool and exciting news. Snyk has just released a collaboration with TryHackMe. Check out the new Snyk code and Snyk open source rooms to explore real-world scenarios, learn to identify and fix vulnerability, and enhance your security skills. Get started with Snyk today, totally for free, and try their new rooms on TryHackMe, all with the links below in the video description. jh.live/Snyk and jh.live/Snyk /THM. Huge thanks to Sneak for sponsoring this video. Okay, what's up, ChatGPT? I have this code. Paste that all in. Let me go back to get our error. Let me actually kind of get a clean slate. We'll run that again just to make sure that I don't have any issues here. Yeah, these are the 3 errors we were working with previously. We can copy and paste this, and let's see what ChatGPT tells me. But I keep getting these errors. Paste that in. Can you please fix this code and give me the syntax to properly create these decryption functions? Let's see how you do with that. Yep, okay. Oh, that should be a cipher, just as we were thinking. Short will not work for us, so it actually is going to define a decrypt mode. You could probably just use the constant rather than make another one there, but that's fine. Now we have decrypt des. You don't need to change the function names, guys. And decrypt blowfish. Void main will do all those things. Yeah, I appreciate the example usage. I literally just wanted you to correct the functions. But this should be fine. We'll copy and paste this for our blowfish capability. We'll do the same for our XOR and decrypt des, and I think we're good that. Let's make those changes. Let me scroll down to our blowfish copy here. Paste that syntax in. Oh, we will need to deal with the arguments though, because those have a different name now. So encrypted text should be first, right? And then the key is what is following that. So presumably that should work. Let's just, again, validate. Will that give us ideally less errors? Let's try to run this. More errors. Back in the code here, we'll go ahead and make these changes, and maybe we could just go back to what it was in case we get any other stupid errors for blowfish, but I think we're good. Fingers crossed, we'll just change those arguments, and now back to the command line. Can we compile? Oh gosh. All right, well the first one isn't bad. That should just be cipher.decrypt mode or defining that variable like they did in ChatGPT's output. But then 153, 157, and 172, okay, same thing whining. So let's fix our cipher decrypt mode. Same thing with our cipher decrypt mode. And what were those other errors again? 148, 149, 53, and 57. Where is that? Okay, that's in L, which would have been our XOR decoder. So we could probably clean that one just as well. Maybe I'm just getting ahead of myself. Let's see if just that inner functionality from ChatGPT would be fine here. And we'll change the variable names as usual for our secret key and encoded text. Do they actually include the key, presumably? Yeah, I think that's what it should have been called. Yeah. All right, so let's try this. Fingers crossed. Okay, now it's just whining about our variable L. Did we get that wrong? Looking back at the original payload, it just defines I. It's declared here as it should be. I think it was the LLI function, yeah, or LII, that ends up just giving it its value and actually defining it. I don't think we copied that line in our rendition. No, we did not. Okay, so let's just slap that in just as well. And white space is going to get all weird and wacky. But, fingers crossed, now we've got this. It's a final variable and it won't like it, so okay, we'll get back to final. Gosh, look at all that stupid back and forth error whack-a-mole, but there we go. Okay, at long last, we've got that to run, or at least compile, and running it will do nothing because all it's doing is displaying our decrypted strings and then letting it happen, but the functions to decrypt them don't print them out right now. So we should actually go ahead and make those changes to make sure that it will display actually the whole string variable here. So whenever it tries to return something new, we can actually just print that out, right? Rather than return, we can actually set that to another variable like output, and then we should be able to system out print line that output variable, right? We will need to add our semicolon there and then return an empty string because this variable or function here does still require a string return type. We did that for our des function. Let's do it just as well for our kind of string XOR here. We can say string output equals. Let's output that with print line. Be sure to return an empty string, because again, we don't care, we just want the output, and we'll do that just as well for our blowfish one. String output equals that. Print line once more to display that output onto the screen, and return an empty string. Now, fingers crossed, if I compile this, no errors, and now when we run it, we see, oh, all of the decrypted strings. This is looking pretty cool. Obviously, look, these are the components for what would be in the actual invoked payload. Our decrypting string, we can see a URL right here, probably where it's going to end up posting to all of the data, application JSON with a header type very likely. And oh, another check IP to Amazon, neat. Some file not found strings that we saw. We actually saw some like file operations in that major function, right? Discord not found and getting Feather accounts, getting Microsoft accounts, user home, Lunar client, Discord. Whoa, is this a regular expression maybe? Okay. But then finally, down below, you might very well be able to see, okay, I don't know what this pizza client and Cole Skyblock mod is. I'll need some other Minecraft folks to fill me in on that one. But the JSON blob that gets sent actually gets the username, unique identifier, their token, probably stolen from Discord or whatever of these, the IP address of the victim, Feather account, essentials information, Lunar and Discord. Oh, that's crazy cool. It is a stealer. It's info stealer malware as a Minecraft mod. That's bonkers. Fake Minecraft mod, right? It's rogue and infected. Now, I gotta be honest, we don't need to drive too far much down the rabbit hole here. If we really wanted to, we could take a look at those strings side by side with where they would be in the original payload. Like if I go back to looking at just our infected tweaks, move that to the side, and then we get into the big function for pre-init, that will end up using the URL IL0, which we've just determined is that URL here, HTTPS, that thing, dxxy on render.com, posting to it with the request method, setting these properties like headers for the content type and application JSON, and everything that would fill in here. If you really, really wanted to, we could do something stupid, either in Java or like Python, keep it easy, to replace those and see that syntax. But look, rather than using some other online tools, like, I don't know, Java Deobfuscator on GitHub, I've always had trouble with that one personally. I don't know if I'm just dumb. Well, I do know that. I am dumb. But I can never get this one working the way that it should. Like, I can go ahead and grab the dependencies. I can set up the detect.yml file and have it work with that and use some transformers, but it never seemed to actually run them for me. And I don't know which transformers I want. My smooth brain, like, run them all. Do it all for me. There is a graphical user interface one where you just check the box to be able to, like, do it. But that had the dependency of Java FX, and I didn't really want to deal with that. I was struggling with that because, oh, you got Java, you want the JRE, you want the JVM, you want the JDK, you want that for version 8, version 9, 10, 11, 18. I don't know. Java's just super annoying and stupid. You heard it. I'm sorry. That's my hot take. So we did it with that stupid hand jam method where we were to zoom out of all the abstraction, all the nonsense, all the LL stupid rename variables and stuff to at least get a basic idea of it stealing some information using the info stealer malware and posting that to all of those locations here, like the command and control server, if you really want to call it that, with that location and taking a look at the data that it would steal. Username, UUID, token, Feather, essentials, that's still pretty crazy. With all that said, hey, thank you so much, David. Big shout out. Thanks so much for sharing this with me, and especially thank you for doing the Good Samaritan stuff to report the GitHub project and the web host address of the attacker. But kind of neat, kind of cool. This was a sweet project and a fun little deobfuscation. Thanks so much. Glad we got to make it into a video. But seriously, I say it all the time, or at least I've said it previously, like, hey, send me malware. Just fire it up. You can contact me. Links below in the video description. Please give some love to our sponsors and do all those YouTube algorithm things. Like, comment, subscribe, and I'll see you in the next video.